All right, gang, this video is going to dive into some problems similar to what you're going to be required to do for your assignment. It's not for credit. Sometimes previously I've given things like this where if you did it, I gave you like a quiz credit or something. There's no credit on this. It's just for your, it's just to help you. So if you go to well, I'll go to Course Tools. If you go to Assignment Manager, there's going to be an assignment that says Practice Problems, HT Video, not for credit. Again, you don't get any credit for this, but it's worth your while to watch because these problems are a lot like what you're going to be asked to do in the corresponding assignment. So I'm going to go preview and just run through these like you would. So. All right, the accompanying data shows reaction distances in centimeters for the dominant hand for 40 independently chosen. Similar distances indicate smaller distances indicate quicker reactions. Okay, so we've got our data, and you can see there's a lot of numbers here, so I want to put those in StatCrunch. And so we have, looks like about 40 measurements. First question, make a graph of the distribution of the sample and describe its shape. So looks like they've got histograms, so I'm going to need to match the histogram. So I need one kind of with a separation right there. And it doesn't look like I have anything. So make a graph for values on the boundary of two bins. Place that. So guys, it looks like to me what they've done here, they've gone from 0 to 24 in bins of, I don't know what, 4 maybe? So let's go back through and change that. All right, start with, we want a width of, let's try 4 in compute. So that's the one that we are looking for. So it looks like to me that this is going to be A. Now, you may ask, well, how did I know that the width should be 4? Well, when I come in here and look at the width of this, 1, 2, 3, 4, that's how I knew. So I'm going to go with A and check answer, and I know I'm going to be right. The distribution is what? Slightly skewed to the right. It's going to be interesting. Find, report, and interpret the 95% confidence interval. Guys, that's going to be easy now that we're into big boy, big girl stuff. So we go to T-stat, we go to one sample, we have our data, select our column, do the confidence interval, and compute. So what do we need to round to what? 2 decimal places. So I have 8.02. Up to 10.91. We know we're right. Interpret the 95% confidence interval. So if the sample was repeated many times, 95% of all confidence interval would contain the true population. Well, that one works for me because it's right. Now, suppose a professor said that the population mean should be 10 centimeters. Test the hypothesis that the population mean is not 10 centimeters with a significance level of 0.05. So guys, first thing we're looking for is mu's. Anything that has anything other than mu can't be, and anything that has anything other than equal to in the null hypothesis can't be. So there's only 3 of them, E, C, and F that could be. And we want to test that it's not 10 centimeters, so I'm looking for not equal to, and C is going to be what I need. Calculate the test statistic. I don't know about you, I'm going to do it the easy way. I'm going to go to stat, t-stats, one sample with data, and I am going to perform the hypothesis test. So I need 10, not equal to 10, right? Is that what we're doing? Yeah. And compute. So the test statistic is negative 0.75. The p-value is right out here, 0.46. Well, it's just 3 places, so we have to regroup. So 0.456. Interpret the results. Since the p-value, now our significance level is 0.05, so it's higher than the significance level of 0.05. We do not reject H sub O. There is insufficient evidence to conclude it's different than 10 centimeters at the significance level of 0.05. Next question. The weights of 4 randomly and independently selected bags of tomatoes labeled 5 pounds were found to be 5.1, 4.9, 5.4, and 5. Using a two-sided alternative hypothesis, should you be able to reject the hypothesis that the population mean is 5 pounds? Why or why not? The confidence interval is reported here. I'm 95% confident between 4.8 and 5.4. Okay, now test. Okay, so A, using should you be able to reject at 5? Well, does our interval contain 5? Well, it does contain 5, so we would not reject. So do not reject the null because the interval does not contain the proposed mean. So it would be B. Oh. No, the interval does contain, so we do not reject because the interval contains the proposed mean. That was silly. Determine the null and alternative. Now test that the population is not 5. So I'm looking for equal to and not equal to. So I'm looking for equal to in my null hypothesis because it's always equal to. And because I'm just testing that it's not 5, I need not equal to. It doesn't say it's less than 5, greater than 5, just not equal to. So we'll have more luck with this one. The test statistic is, well, I'm going to write these values down, 5.1, 4.9, 5.4, and 5, and I'm going to enter those manually into variable 2. And just to keep it straight, I'm going to call it tomatoes. Tomatoes, that's good. Now, so I need 5.1, 4.9, 5.4, and 5. Okay, now what do I need? I need the test statistic. Testing 5 against not equal to 5. So stat, t-stat, one sample with data. I want tomato. Hypothesis testing is equal to 5 and not equal to 5. So the test statistic is 0.93. And the p-value is 0.423. It wanted me to do 3 places before, so I'm assuming that's what it wanted here. All right, since the p-value is greater than the significance level, do not reject H sub O. There is insufficient evidence to. All right, a random sample of 20 independent female college-age dancers was obtained and their heights were measured. Assume the population is normal. A one-sided test with a significance level of 0.05 is previously performed on the data and the null was rejected. Use the data to find a 95% confidence interval for the mean height. If a two-sided alternative had been used, would the hypothesized mean of 64.5 have been rejected? So we need to pop that into StatCrunch. And we want to create a 95% confidence interval. So we're at 61.92. To 64.13. Next, test the two-sided alternative. So two-sided means the alternative has to be not equal to. So we know it has to be mu equals 64.5 and not equal to in the alternative hypothesis. So F has to be a two-sided. The test statistic, guys, we have to repeat what we just did. But this time we're going to do the t-stat, one sample with data, select variable 1, and we need, let me go back to that one, 64.5 and not equal to. All right, compute. And the test statistic is negative 2.80. The p-value is 0.012, right? Now, since the p-value is less than the significant level, we reject H sub O, and there is sufficient evidence to conclude the population mean is different than 64.5. All right, the following numbers are the differences in pulse rates before and after running for 12 randomly selected people. Test that the hypothesis, the mean difference in pulse, was more than 0. So guys, I'm looking always for equal to in the null hypothesis, and now I'm looking at greater than because it says more than 0 in the alternative hypothesis. So I'm going with this one. The test statistic. Well, we've got to get that in StatCrunch. Test statistic tells me I need to do a hypothesis test. I'm testing 0 against greater than 0, right? Yep. Test statistic is 3.88. The p-value is 0.001. The p-value is less than the significance level. Reject H sub O. Therefore, there is sufficient evidence to conclude the population mean is more than 0 beats per minute. All right, guys, that's it. There's only one more video, and it's only going to be 2 or 3 minutes. I'm going to show you when there's when the confidence interval and a test of hypothesis doesn't line up. But guys, we're about done with hypothesis testing for means. So hopefully, through all the the many videos that you've watched or should have watched, you're better at this now. So take care.